Welcome, everybody, to another Monday edition of Dirt Talk. We'll do Draglines first and then get into Q&A.
Yeah.
All right, we're recording two. So this first one is about draglines, everything you need to know about draglines. It's not actually everything you need to know. I don't know everything there is to know. This is just based on what I know about these machines, but fortunately, I've been around quite a few of them over the past few years. So I'm going to do my best to explain the machines, the company that uses the most of them in North America, and then answer some common questions. Before we get into the machines, the draglines, let's talk a little bit about North American Coal, which is the company that uses draglines all over the United States. Technically, NACCO, North American Coal being one of the NACCO companies, North American Mining, which also uses many draglines, being one of the others. I will go into detail about North American Coal and NACCO in a later episode down the road, but I just wanted to provide a little bit of context here. The company began in 1913 as the Cleveland and Western Coal Company. They started primarily underground mining in West Virginia, Ohio, and Pennsylvania, mining coal, obviously. In 1956, they went public, and after that, bought their first lignite operation in North Dakota. 1 year, and so in 1957. And then in the 1970s, they secured management contracts to help develop and operate the Freedom and Falkirk mines, where they still operate today. And those are the mines that I have visited with them that are absolutely spectacular. Two of my favorite mines in the world to visit. In 1988, they exited the underground mining business. So after that, they focused exclusively on surface mining, which is what they do today. And just as a side note, NACCO Industries, which is the holding company that owns all of the subsidiaries, back in the day, also produced anything from forklifts to blenders. But we won't go into the offerings that they had for the kitchen. Nowadays, they do anything from large coal mines to aggregate mining to environmental mitigation. The company's amazing. I could not be a bigger fan of NACCO Industries, of North American Coal, of Mitigation Resources, of North American Mining. I am a big, big, big fan of this company. So that's a little bit about NACCO. Their model, which is important. We're almost to the draglines. But North American Coal's model is very important for some context here. In short, they're a mine operator working on long-term contracts. So they have multi-year, sometimes multi-decade contracts to operate these mines that they work on. They maintain the equipment and operate the mine itself for a client, which is typically, for the coal side, a power company. And their coal mines are known as mine to mouth. They do not sell coal on the open market. Instead, the coal that they mine travels directly to their customers, often only miles away. So at most mines that they operate, the coal haulers or the trucks hauling the coal dump right into a feeder that feeds almost immediately into the power plant.
And do the power plants own basically the raw material?
Yeah. So the power company owns everything, and it's different everywhere. North American Coal, they're the operator.
Nice.
Now, draglines, just a little bit of history on these monster machines. When it comes to American surface coal mining, draglines have been the absolute undisputed king for decades. The golden era for these engineering marvels was in the 50s, 60s, 70s, which was when the American coal demand was really growing significantly across the entire country. They operated back in the day anywhere from Wyoming's Powder River Basin to the Indiana coal field. And so they've used draglines all across the United States, and that was the primary weapon for any surface coal mining operation typically. The two big players back in the day were Bucyrus Erie, which is now Caterpillar, and Marion, which is technically also now Caterpillar. Go figure.
Yeah.
The biggest and most well-known dragline was Big Muskie, which Bucyrus Erie built in 1969 for the Central Ohio Coal Company. But unfortunately, as coal's been phased out in America, so has the dragline. So Big Muskie, so sad, but Big Muskie was scrapped in the 90s along with many other extraordinary machines over the recent decades. Most of those still operating, the draglines that are operating today are at least 30 years old, many decades old. And depending on the maintenance program, they can run well over half a century without issues, which is pretty spectacular. Most people ask a common question regarding that is, why aren't there new draglines? And it's just because they are wildly expensive. I think for Caterpillar to build you a new dragline, it's well over $100 million, which is a huge capital expense. And so as coal's been phased out, a lot of draglines have come available. And so the current operators of draglines, like a NACCO, have bought those used draglines and have oftentimes moved and rebuilt those draglines to serve other purposes. So it's not a really growing market, which is why you don't typically see new draglines, big draglines. There's new, smaller draglines, but not the real monsters.
Because those are one of one. I mean, they make them specifically, right?
They're essentially, bespoke. It's one of one. Every machine is a little bit different.
Awesome.
Why are draglines good for coal? Well, let me tell you. Most open cut coal mining is known as strip mining. The mining companies, like in North American Coal, open up strips, typically only a few hundred yards wide, but sometimes miles long. So think of just a long, narrow strip all the way across the land. The seams of coal can be typically anywhere from 10 to 100 feet deep, and they're covered by worthless dirt called overburden. And so the faster and cheaper the operation can move the overburden, the cheaper the coal it can produce, which means the more affordable power for everybody at the other end. And since draglines swing enormous buckets and are powered by electricity instead of diesel, they can move the overburden far cheaper per yard than conventional truck and shovel fleets. It's all about cost per yard. And not only is their cost per yard low, but they also jumpstart the necessary reclamation process by casting the overburden from the current strip into the previously mined strip. And then once dozers flatten out the spoil piles, trucks place topsoil, and in only years the land is back to its original state or better. And then once the dragline exposes the coal, a dozer cleans it up, and then loaders or shovels will mine it. So the draglines are not actually doing the coal mining. They are just removing the earth from atop the coal. They are placing that earth on the previously mined strip to start the reclamation process. And then the coal mining process comes through. The dragline then moves over to the next strip, and they just advance across the land strip by strip by strip by strip.
Yeah. I think that's important to note because before I came here and before I learned a little bit more about mining, strip mining seemed like a dirty practice, like a dirty word. I was like, well, they strip all the materials from like a mountain or something. Yeah. And I think a lot of people think about it in that sense, but no, it's the actual just makeup of, like, it's just how it looks.
Yeah,
like,
no, it's the process.
And it's the process. It's not like there's just stripping resources.
And strip mining is awesome because of that continuous reclamation. So as they progress, that reclamation chases the cut. And as you can, if you look at a mine from an aerial standpoint, you can see how the reclamation progresses. And the land that's been mined 10, 20, 30 years ago, there's no telling that anything was there. It's really, really spectacular.
I wonder if they have like satellite imagery.
They do. Yeah.
Years of like.
They do. Yeah. There's some time lapses on the internet that are
that's sick.
Crazy cool. Cool. So to get to, we've seen a lot of draglines, but I'm going to get to the specific dragline we most recently saw and went inside of. Bringing us back to North American Coal, we visited their Freedom mine this February to check out one of their draglines up close, which is called the Missouri Quest, a Bucyrus Erie 2570. Every dragline has a name, like a boat.
Yeah.
And so this was the Missouri Quest. The machine was built in the early 80s and has not left the mine since, as it runs nearly 24/7, 365 days a year. The machine has over 238,000 hours on it. And in each 12-hour shift, the machine can move between 60 and 70,000 cubic yards of material, with its record being almost 90,000 yards. And I apologize to our listeners in the other parts of the world. I did not convert this to metric as I should have.
Well, you're going to have to do math anyways.
You can do the math on your own.
Yep.
So that's the machine we're checking out here and talking about. Everybody always asks, what kind of bucket does it have on it? That's the business end. That's why we're here.
A big one.
A big one. The bucket on this one's rated for well over 100 yards of earth, or about 215 tons per pass. They change the teeth out on average every 3 weeks. And then North American Coal also keeps multiple buckets on site at all times. They swap the buckets out on average every 6 months. And once a bucket is worn, they spend months rebuilding it to the required specifications before putting it back into service. So you don't just buy new buckets for these. The buckets are many millions of dollars each and are purpose built for the specific dragline, specific operation. It's a custom order. But once you get buckets, you can rebuild them over many years. And so you're using those same buckets and you're just swapping them in and out as the machine continues to run.
Yeah.
How does it run? Well, first it has a giant extension cord traveling thousands of feet from an on-site substation. The cord's roughly the diameter of a soda can, and it feeds the entire machine. And then, like a warehouse, the house is where all the main components lie. So if you look at the dragline, it's essentially this big rectangle. That's what we're talking about. We're talking about the house here. If you're standing looking out over the house from inside, we have the swing motors toward the front, which help the machine swing in either direction using enormous gears, huge gears. In the middle, we have 2 giant drums powered by 8 electric motors each. One drum, I think it's 8, 4 on either side. One drum controls the drag cables, and the other controls the hoist cables. So all you have attached to the bucket, you have 2 drag cables in front, pulling the bucket in and letting the bucket out. And then you have the 2 hoist cables lifting the bucket up, lowering the bucket. That's really all there is to it.
Yeah. So you have just basically 2 directions and then swing left and right.
That's exactly it. And then in the back of the house lie a long list of generators to power the overall machine, everything else on board.
Yeah.
It's really simple, but it's complicated. You look at it, it's a spectacular machine, an engineering marvel, but it's at its simple. It's very simple.
Like at face value, you're like, yeah, this makes a bunch of sense.
All you're doing is just dragging a bucket in and out, and lifting it up and down, and then to dump, you just let the drag cable out while keeping the hoist cable in place, and the bucket falls forward. The material falls right out.
Yeah, it's a really cool process, and the operators have a very certain type of finesse with.
Totally,
it's a very specialized skill.
Well, and that's a good segue to how many people does it take to run one of these? Well, draglines typically operate with a 3-person crew. The first of the 3 is the ground person, which spends most of their time on the ground. They function as the dragline spotter as it moves, and they manage the power cable as it moves with a farming style tractor. They have John Deere tractors out there with a little cable handler on the back. And then as the machine operates, this crew member can also run a dozer to help build a solid and flat pad for the machine as it advances. So there's a D10 out there. The operator can grade off the pad. So as the machine goes, you want it to be as smooth as possible. It's like a grading job. Mm-hmm. And that D10 cuts it to where it needs to be. So that drag line's straight up and down. Second, take a drink here. Second, we have the oiler. And the oilers on board the machine perform constant maintenance. Constant maintenance. That's a key term. Constant. Since it's so enormous, each oiler only has a portion of the machine that they carefully look after while keeping their eyes on the entire machine while it's operating. They coordinate with the operator to check the machine every shift for issues. And so while they're operating, that oiler is in charge of the overall machine, but only in charge of a specific quadrant of the machine when it comes to the really detailed work, if that makes sense.
Yeah, so they do it kind of, section by section.
Yeah, and so then another oiler on another shift will have another section, another section, another section.
So hey, this quarter of the machine is mine.
Yes. Yeah. It's just so wild. And these are old machines, so they require non-stop maintenance to make sure. Yeah. And they're essential to the operation. If one of these machines goes down, the mine goes down.
Yeah.
So they have to make sure they have eyes on these machines at all times. And so this person, all their job is to just make sure the machine continues to move.
Mm-hmm.
And then finally, we of course have the operator, who has typically served already on the ground and in the house. They've already done the other roles. That's how they come up, where all the components lie. And operating one of these looks mind-numbing to the untrained eye, but I've never met a dragline operator who doesn't absolutely love their role. Absolutely. It's nonstop mental math to fill every single bucket and to care for those machines. They're so enormous. It requires so much finesse, so much planning. They're digging their cuts in a very specific way. They're placing the material in a very specific way. They're coordinating with the person on the ground. They're coordinating with the oiler. They're coordinating with the dozer down in the pit potentially, and then other crew members and maintenance. And there's so much there that I don't think it's ever boring for at least the right kind of person.
Yeah.
And then while everybody on the crew can operate the machine, the 3-person team usually sticks to their specific roles.
So there's usually just one person in the cab.
Yeah.
Or
yeah.
I guess, I don't.
But the oiler technically can run the dragline.
Oh, okay.
Yeah.
Yeah. It's probably how a lot of operators got their job.
Like the space shuttle.
No.
Yeah.
Yeah.
I guess everybody.
So the ground person is, I think that's a kind of funny role, because I imagine them walking past one of the John Deere tractors and kicking out the cable. The whole thing just shuts down.
Yeah, but if you unplug it, the whole thing just shuts down.
Obviously that wouldn't happen.
Yeah.
It's 3-phase power.
You trip on the extension cord and you pull it out of the wall.
Yeah, and in my mind it's a massive extension cord, and it's someone trips over it.
Yeah,
it's fuck.
They have to go into it, wrestle it into a three-prong GFCI socket.
Yeah. But it's just massive.
Yeah. The controls. How do you control it? Well, first it has 2 identical cabs, one on either side of the machine. And they choose which cab to use depending on how the machine is set up within the mine. And so the Missouri Quest specifically, they typically stick to the right cab with how it is oriented within the mine for the sake of visibility.
On the English side?
On the, yes. Yeah. Right-hand drive.
Yeah.
And then the controls are actually quite simple. All it really is a seat with 2 joysticks that control the entire machine.
Crazy.
And so forward, backwards on the right stick hoists up and down. So that's your hoist. And then left and right on the right stick is your swing in either in the corresponding direction.
Okay.
And then on the left stick, forward, backward is drag out, drag in. And then left, right on this machine doesn't do anything.
Oh.
So that's all it is. You've got your hoist and swing on your right hand.
Yep.
Your drag in, drag out on your left hand.
So that the drag in, drag it out controls the kind of the tilt of the shovel.
It kind of, yeah. It lets the bucket out or brings the bucket in, and it's a drag line, and so it cuts by leveraging the weight of the bucket itself.
Yeah, it's
super heavy.
massive.
So as you're leveraging the weight, and then you're pulling on the drag cables, and you're dragging that bucket across the earth, which then fills up the bucket.
Kind of like a giant anchor where it kind of...
Yeah, and it's all you're using. It's the weight of the bucket, the force of the bucket on the earth, and then the force of those two steel cables pulling it forward. That's it, like a giant plow.
Yeah, that's crazy.
So that's the controls. How does it move? Well, they don't call them walking draglines for nothing. They walk. That's how they move.
Very slowly.
Very, very slowly. The entire machine sits on a gigantic circular bit of steel called the tub. And whenever the machine is operating, the tub is flat on the ground to distribute weight evenly. So it's on a giant cylinder. And as the machine's moving and as the machine's operating, that cylinder is resting on the ground, distributing the weight of the entire machine on atop that cylinder.
That's crazy.
And then when it's time to move, which is not that often, the dragline uses its 2 feet, which are technically called shoes, to scoot itself along. So it has, if you look at it, there's giant pontoons on either side of the house. And the walking mechanism on either side pushes those shoes into the earth and then lifts up one side of the machine as it drags the other side of the machine along the earth. So the machine itself, the tub, is never actually fully off the ground. It's not actually lifting up the entirety of the machine. It's just lifting up half the machine and scooting the other half along the ground.
So it kind of...
like scooting itself.
Yeah, like goes from side to side.
No. It lifts everything up evenly and then scoots itself forward.
Oh, okay.
And as it's moving forward, it's just dragging the other side of the machine along.
I see. So it's kind of like an inchworm.
Yes. Yeah. Kinda.
Instead of like from side to side. Okay.
Yeah,
I never fully understood that.
Every revolution takes about 45 seconds, and it moves the machine 8 feet at a time.
Oh.
And so when they finish each cut, walking the machine back to the other side takes about a full day.
That's cool. I never really fully knew how that process worked.
Yeah, I didn't either until I saw it. And then it's like, well, this makes, I guess, perfect sense. Draglines are really, really simple, but there's a lot to them. So much planning, because you don't just move the machine. It's a big process, a big undertaking. It's very expensive.
Yeah.
And so every one of these cuts is very well planned. And they're already planning where that machine is going 3-6 months from now.
So, like, when it's not walking, are those motors just like offline?
Yeah. The shoes are just kind of up in the air.
Yeah.
When it's not, and then the only time they're contacting the earth is when it's moving. Yeah. And then when it's not moving, that entire tub is on the ground.
But there's specific like motors for the shoes. Mm-hmm. Yeah.
Yeah. It's like a giant, it revolves.
Yeah.
So it's to push down and pull back up.
Kind of like a piston
movement. Yeah, kind of like a piston movement.
Like if you see like the bottom end of a motor, like the crank.
Yeah.
I'm assuming it's something similar.
It's something similar to that. Yeah, exactly.
That's cool. So
that's a little bit about NACCO, North American Coal, draglines. We go into detail about all of this on a recent YouTube video. We have about a 15-minute video of us actually touring this exact machine I'm talking about. Mm-hmm. And so if you want to see it in detail, you can just search Aaron Witt or Build Witt on YouTube to watch. It's actually quite interesting. It's one of my favorite videos we've done in a very, very long time.
How many times have you been to this mine now?
3, every time in winter, which I like. And so that's
it looks
the
good.
thing.
Yeah.
Oh, it looks good, but that's the reality is they operate, again, 365 days a year. They do not stop. And if they stop power to many states, to hundreds of thousands, millions of people stop. They can't stop. And so while sure, the operator, the oiler, oftentimes the person on the ground, they're in a heated cab. Mm-hmm. The maintenance on these machines, sometimes you have to do it when it's cold out. You have to change out the drag, the ropes, the steel cables. You have to change out components every once in a while. Like there's giant, essentially bay doors in the back of the machine. There's a 30-ton crane inside the machine, and you can swing components out of the machine as necessary. And then
I forgot about that. That they have a dedicated crane in this.
And then you have to change the teeth. You got to change out the bucket. All that's happening, rain, shine, winter, summer, doesn't matter.
Yeah, they don't get to pick and choose when they're working.
No, they have to keep that machine moving.
Yeah.
And it works quite a ways ahead of the coal mining operations, but coal mining operations are chasing after them.
And then, so after the dragline does its thing, they push the seams over with dozers, right?
No, they mine the coal with loaders or shovels.
Okay.
And then once all the coal's gone, then that, the dragline makes its next pass.
Shifts over.
And that's where they just mine the coal is where he's dumping the spoils on that next strip.
Cool.
Yeah.
Yeah.
So hopefully I explained that well enough. I tried to be as descriptive as I could when I was thinking about how to talk about this.
Yeah. Well, go check out the YouTube.
Yeah, it's way better on the video, but I thought this was worth making a podcast about too, because these are amazing machines, and unfortunately, not many people actually get to see them nowadays.
Yes, they're kind of a dying breed.
Oh, it's such a shame because they are so spectacular. So hopefully you enjoyed that. If you want to learn more about NACCO, it's just NACCO.com, NACCO. They're amazing folks. Thanks for having us out, NACCO, North American Coal up in North Dakota. And we'll see you on the next Monday edition of Dirt Talk. Thanks for listening. If you have feedback for us, send it to dirttalk@beulah.com.
Go straight to me.
Go straight to Harrison. Later, gang.